Here's an explanation of some of the ideas from sections 4.7, which is graphing systems of linear inequalities. And in this case, it's going to be inequalities like we've done before, but now we'll have two variables and we'll have two inequalities. And you want to find the ordered pairs that satisfy both inequalities at the same time. So here's a word problem that can explain what I mean. So Christy wants to sell photographs at a fair, at the street fair. At the start of the day, she wants to have at least 25 photographs to display. Each small photo costs her $4, and each large photo costs $10. And the last piece of information is she doesn't want to spend more than $200 on the total for the display. So they want us to set up a system of equations, set up variables and inequalities, and they also want us to then graph those inequalities to see what ordered pairs are going to be solutions, and then check, is it possible for her to do 10 small and 20 large photos? Does that satisfy those two inequalities? And second, they put can she also do 20 large and 10 small photos? But that's exactly the same thing. So I'm pretty sure they meant to switch these and ask if she could do 20 small and 10 large photos. Is that a situation that would satisfy her two constraints? So what are the variables? The variables are how many small photos, that's X, and how many large photos, that's Y. So we get two inequalities. One is she wants to have at least 25 photos to display. She wants to have a lot of display. Second, she wants to have a less than $200 total cost. So the total cost is going to be 4 times the number of small photos plus $10 per large photo times the number of large photos. So that's 4x plus 10y is less than or equal to 200. So how do we find the values for the ordered pairs, x and y, that satisfy both of those at the same time? The way we're going to do it is we're going to graph the system. And what you do to graph x plus y greater than or equal to 25 is you graph the line x plus y equals 25. And one way to do that is to solve for y and write it in the form y equals mx plus b, and then you know the y-intercept and you can figure out the slope and solve. So in this case, the slope is -1, -1 times x plus 25. And so that looks like a graph here. We get a nice y-intercept at the point 0, 25, and the slope is -1. And then, so you can kind of figure out the slope there. And then to draw the graph, you'd like to know this point down here. And so you can calculate that, but it turns out it's 25. And so that's the point 25, 0. And so that's the situation where she makes 25 of the small photographs and 0 of the large photographs. This point up here is 0 of the small and 25 large. Now we have to figure out the cost. So let's look at the inequality for the cost. How can you easily graph this equation? And we're going to forget the inequality part while we graph it and just look at the equality part. One thing, you could solve for y and get it into the y equals mx plus b form. It's easy to find then the y-intercept is 20 and the slope is -4/10 or -2/5 if you simplify. But that's still difficult to graph. You've got to count the rise and the run and draw some points. Another way to do these quickly and easily is to look at the two intercepts. If you've got a form, if you have an equation that looks like this, 4x plus 10y is greater than or equal to some value, it's easy to find the two intercepts. You find the x-intercept by setting y equal to 0. In that case, we have 4x equals 200 because the 10y disappears, and x equals 50. So that's the point over here, 50, 0. That's easy to find. And then we can do the same for the y-intercept, where we set x equal to 0 to find where it crosses the y-axis. And if x is 0, the 4x disappears, and we get 10y equals 200, or y equals 20. And so that's this nice point up here, 0, 20. And so the blue line then becomes our cost inequality. okay? And so you can graph those two equations using whatever methods you want, either solve for y and use the slope-intercept form, or do the two intercepts. Find the x-intercept and the y-intercept. You have your 2 points and you can connect the line pretty easily. So then the question is, once we've graphed that, what are the solutions to it? So are these 2 points solutions? So one thing you can do is you can plug those in. So what happens in this case if she decides to do 10 small photographs and 20 large photographs? Well, she's got at least 25, because 10 plus, she's got 30, so that's greater than 25. But what's the cost? It's 40 plus 200 is 240, which is greater than 200. So that's not what she wants. 200. So that's bad. It's not a solution, all right? What about if she does the other way and does 20 small and 10 large? Again, she's got more than 25, so she's happy. And the cost is going to be 80 plus 100 is 180, which is less than her 200. So that's good. So that's a solution. So the point 2010 is a solution. So you can pick any point you want and verify that it works. And let's look what happens on the graph as you do that. So one of the things that we'll talk about is the blue line is her cost, right? And you want the cost to be less than 200. So your points should be below the blue line. So they should be, let's do blue, down here, down below that blue line, right? But she wants the red line is the number of photos that she wants to do. So you want it to be at least the red line, so above the red line. So what are the good values? Can you graph all the solution? I'll do that in green. It's going to be below the blue, above the red. But it's got to also be positive. Down here, let me color down. Down here is bad, right? Because in real life, she can't have negative 5 of the large photos. That doesn't work. So the real solutions are only that green triangle. So you've also, they don't say it, but you have to have y is greater than 0 and x is greater than 0. So you have to have a positive number of photographs for each case. So you can see when you're done with this, that green triangle are the possible combinations that she could have. She could make 50 of the small and none of the large. She could do 30 of the small and 5 of the large, things like that. 30 and 5 are good solutions to her situation. So we're going to try and do that in a lot of applications where you have constraints. You have to have at least this many of something, and the cost has to be at most this, or you'll see some examples where we'll do that.